નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Welcome students to ninth part of 13th chapter Fun with Magnets of Standard 6th Science. In the last part, we understand how to make our own magnet and we did so. And then after we discuss how to make our own compass box. That what we discussed in the last part. Now in this part, we are going to learn attraction and repulsion between magnets. So before starting in the textbook, before reading in the textbook, let's try to understand repulsion and attraction of the in between the magnets, and then after we will read the textbook. So for that, let's do this. Suppose I have the magnets, 2 bar magnets I have. Okay. Now let me show you one of the thing is that there is a dot over here, and in the same way there is a dot over here in this magnet. That means what? It indicates that both the poles are same, this pole and this pole. I don't know whether it is north or south. Actually it is north pole, but both these poles are same. Okay. Now why I am explaining this? Suppose let me keep this dot wala bar somewhere over here. Okay. Now I kept like this, and the same dot is over here, and the same dot is over here. Now let's see what happens. See, both the dot wala pole I am keeping nearby to the another magnet. Then that means what? Both the north poles are there, isn't it? And this is a south pole. If this is a north pole, then this is a south pole. Let me keep this south pole first to this north pole. Let's see what happens. Okay, they attract each other. They attract each other. Means what? This is north pole, this is south pole, and if I keep nearby, if I bring these poles, opposite pole we can say, north and south, both are opposite to each other. So I can say opposite poles nearby to each other, then what happens? They attract each other. Now let's see if we bring same pole. If we bring same pole of the magnets near, then what happens? Let's see. This is a north pole. This is over here also. There is a north pole itself, isn't it? So let's see what happens if we bring same pole. Let's see. Can you see? This magnet, the other magnet, is moving away from the first one. Can you see? Can you see they are moving away? Let's see once again. See. So this same pole, if we bring same pole together, then we can come to know that same poles repulse each other, and the unlike pole, we can say unlike pole, opposite pole, unlike pole attracts each other. See, attraction is there, that means both these poles are unlike. If there is an attraction, that means we come to know that there is unlike pole. Both the poles are unlike pole. Now suppose this is a magnet, isn't it? Now I don't know the pole of this magnet. If I want to see how to find out the pole of the magnet? I have a bar magnet, and in this bar magnet I know that this is a north pole, this is a north pole, I know that. Now if I want to find out the pole of this magnet, where are the poles of this magnet? It is not written anywhere. Now how can I find out? Then there is a simple thing. If the opposite, unlike poles, if I will bring together, then they will attract each other. And if the poles, if I will bring this any side of this one and it do not attract, that means those are like poles. Okay, so let's do like this. Here you can see there is a north pole of this magnet, and I am bringing this side towards this magnet. Let's see what happens. Both the poles attracted. Okay, this one is attracted somewhere over here in this side. That means you can see, we know that this is the north pole of this magnet, and this side is this circle, or this side is attracted, means this side is this is the side of this magnet is a south pole, isn't it? Now if I will bring this south pole, let me keep south pole towards this. This is the south pole, and this is also a south pole. So if I will bring towards this, then let's see. This is going, you can see, this is going away. This is going away from this. Can you see? It is going away. That means what? This is the south pole of this circle, this magnet. This is the south pole, and this is the north pole. So through this we can come to know also. Okay, we can decide that which pole is where. Okay. So the main thing we come to know is that like poles of a magnet. What are like poles? North, north, south, south. Like poles. Like poles of a magnet repel each other, and whereas unlike poles attract each other. That we come to know through this activity. Now the same thing is explained in the textbook. I will read the textbook and try to make you understand through the textbook. Why? Because there is an activity like, but I will try to make you understand through that, so that you can understand, and then after we will go for discussion something else. So open page number 131 in your textbook. The point 13.5, attraction and repulsion between the magnets. Let us play another interesting game with magnets. Take two small toy cars and label them A and B. Place a bar magnet on top of each car along its length and fix them with rubber bands. You can see cars are there. Cars are there, and on each there are magnets. Total 4 cars are there, A, B, C, D, and there are magnets. And the magnets having blue and red colors, so that we can understand their poles. Okay. In a car, keep the south pole of the magnet in car A. Keep the south pole of the magnet towards its front. Place the magnet in opposite direction in car B. Place 2 cars close to one another. What do you observe? Now, see, in car A, south pole is on the front, and in car B, north pole is on front. So if we bring those cars, place cars close to one another, facing their front, then they will attract each other. Why? Because south pole and north pole together, that means they will attract together. Do the cars remain at their place? Do the cars run away from each other? Do they move towards each other? They move towards each other. And cold. Record your observation in table as shown in table 13.3. Now place the toy cars close to each other such that the car rear side of the car A faces the front side of the car B. Do they move as before? No, they will not move as before. Why? Because like poles will come together, and that is why they will move away from each other. Okay, next, place car A behind car B and note the opposite direction. Now, if we put car A behind car B, then once again unlike poles will come together, and that means they will attract together. Okay, you can do it with yourself also and try to fill table 13.3 with yourself. Why? Because you know now which are like poles, unlike poles, what will happen to them. What do we find from this activity? Do two similar poles attract or repel each other? What about opposite poles? Do they attract or repel? We come to know. We already come to know that unlike poles attract each other and like poles repel each other. This property of the magnet can also be observed by suspending a magnet and bringing one by one poles of another magnet near it. Now, a few questions are there. Let's try to understand those questions. These are also very important. Magnets lose their property if they are heated. Remember this one, and everything in this one is important. Why? Because this is your question. So, magnets lose property if they are heated, hammered, or dropped from some height. Magnets lose their property if they are heated, hammered, or dropped from the height. Also, magnets become weak. Magnets become weak if they are not stored properly. If they are not stored properly, to keep them safe, bar magnets should be kept in pairs with their unlike poles on the same side. Remember that. Bar magnets should be kept in pairs with their unlike poles on the same side. They must be separated by a piece of wood, while two pieces of soft iron should be placed across their ends. Okay, let me make you understand. Suppose, see, these two bar magnets with me. I have a box for that. Okay. Now, first of all, see, this is the north pole, and here once again north pole. Then I should keep unlike poles together. Okay. And same side you must separate it by a piece of wood. Okay. See, this is attracting. That means this is unlike poles. Okay. Now I have a box for that. And you can see there is a piece of wood. Okay. Now I should keep this north pole. Then here I should keep the south pole of this one. You can see south pole. But in between I should keep this. Wood. Piece of wood, and once again I should keep like this. Now you can see, this is north pole, then this is south pole. This is north pole, then this is south pole. Okay, and I should keep in between, I should keep a wood piece. Okay, like that it should be kept. Otherwise, the property of this magnet will become weak. Okay, let's go further. By a piece of wood, while two pieces of soft iron should be placed across their ends for horseshoe magnet, one should keep a piece of iron across the poles. You can see. See, this is for bar magnet. This is for horseshoe magnet. Then one should keep a piece of iron across the poles if it is a horseshoe magnet. Now some other things are also there. Keep magnets away from cassettes, mobiles, television, music system, compact discs. From these all things we should keep away our magnet. Okay, and computer also, yeah. And computer also. You might not have seen those cassettes. You might not have seen, but from the cassettes, mobiles, television, music system, compact disc, and computer, we should keep away the magnet. Okay. So this is the end of this chapter. But we come to know two properties of the magnet. One of the properties is what? Magnets always take rest in north-south direction. And the other property is what? Like poles of the magnet repel each other and unlike poles attract each other. So these are the two properties of the magnets. And we discuss the activities also in this chapter. With this we are ending this chapter. Read your textbook as well as both these videos repetitively. Thank you. Thank you for joining us. Take care of yourselves and we'll meet you in the next session. Thank you.